Okay, so it's 3:15 and we'll get started. So good morning, all of you, and welcome to this deep dive session on application insights analytics. Now, imagine that all of you are, let's say, based in US, you have web applications or services running across the world, and you have instrumented it with application insights, collecting all sorts of telemetry, events, logs from your application. Now, towards the end of your working day, you suddenly get an email alert saying there is some weird problem going on with your application and there are failures coming up in Asia. Now, the day is just starting in Asia, and if you do not detect and fix the problem in the next couple of hours, you are going to start lose business. Now, what do? Of course, you are collecting these tons of logs and events from your application. You have terabytes of information that you would have to mine through to figure out what's going wrong. And that's exactly what we are going to focus on today. We are going to discover and learn how we can use analytics to mine through this terabytes of data that we are collecting from our application, discover problems and patterns, identify the root cause, and eventually go on to fix the issue. I am Rahul Bagaria, a Senior Product Manager in Application Insights, and I have here with me Evgeny Tarnowski, who is a Program Manager and an expert on analytics. And do keep track of our Twitter handle at App Insights. So if you ever want to say hi or tweet to us, we are always there. Now, I'm sure many of you would already know what is application insights and would have tried with your applications. But for those of you who are new to that, I'll spend maybe a few minutes in the beginning to give an overview so that we are all on the same page before we deep dive into analytics. When we are at analytics, we'll go through the query language, which is like an interesting experience in itself. We will demo some of the common scenarios that we believe would be most important to you. And since it's a level 400 session, that will be the key focus of our talk today. At the end, we'll take questions and share any resources that might be interesting. Okay? Now, what is application insights? It is an APM and analytics service for your web apps and services built on any platform, any language, deployed on any infrastructure, be it on-prem or cloud. Now, I like to talk about it in three phases. The first one is data collection. Now, we collect data from each tier of your modern application, be it server backend, middleware, dependencies, even client-facing front-end or APIs. Now, most of this data is collected out of the box. You don't have to write a single line of code, and you can collect all sorts of performance metrics, dependencies, logs, and various other data points. We do have an SDK and an API surface area with which you can send custom events and instrumentation if you ever need. Now, all this data is sent to our Azure cloud backend, where it is stored and processed, and we apply some machine learning algorithms on top of that so that we can identify patterns, do proactive diagnostics, and give you some real-time alerts. Once we have all these KPIs and reports in place, you can now go ahead and play with this data in various different forums. You can go to the Azure portal, where App Insights service is hosted, and you can do the APM stuff there. You can detect, triage, diagnose information. You can head on to our analytics portal, where you can ask all sorts of creative ad hoc queries and get instant results over your data. And that's what we are going to talk about today in detail. You can even extend and customize your experience and integrate App Insights with your existing DevOps workflows. And we'll touch base on that as well in a second. So over the past few months, we have been talking to customers and identified three key areas that we have been focusing application insights on. And I believe these three would be resonating with all of you quite as well. The first one is intelligent APM. Now, with application insights, you can detect, triage, and diagnose information about your applications. Now, of course, as analysts, you need not want to sit in front of your dashboards day in and day out, figure out what's going wrong, identify patterns, and so on. Now, with our machine learning technology, we can proactively identify anomalies and service degradations in your application and give you a real-time alert based on what's going wrong. So you can focus on what's most important, that's finding and fixing problems. And we had a session focusing on this in the afternoon by Victor, which if you missed, you can always see online. The next one is my favorite part of application insights, that's instant analytics. Now, with analytics, you can ask all sorts of ad hoc queries over your telemetry data that we are collecting. These can be queries on performance, diagnostics, can be usage analytics queries, or even interesting machine learning queries on top of your data, which we'll see in our demos. And this will be the focus of our talk today. The third one is integrated DevOps. Now, of course, application insights provides incredible deep diagnostics experience for your applications. But you can extend and enhance that experience by using our open source SDKs and data access APIs to integrate with your existing scenarios. You can even integrate with your other DevOps tools and processes if you're using, say, Visual Studio Team Services, SCOM, OMS, Azure, GitHub, and whatnot. So App Insights has a seamless integration with these services, which can make your life a whole lot easier. And if you have any questions around this, we have a booth in the expo hall where you can come, and we'll be happy to show you more details on how to take advantage of these integrations. Now, it's high time we saw the actual product and see the power and the capability. So I'll switch on to that. Now, what we're seeing here is the Azure portal, which many of you would already be familiar with. Now, this is a dashboard that I have created based on my application KPIs, charts, or parameters that I want to look at on a day-to-day basis. Let me zoom it a bit so you can see more clearly. So here you can see things like my availability tests, my application topology. We have server performance, client-side performance, failures, and various other things that might be interesting to me. I can click on, so let me zoom back. I can click on my application component, jump onto the application insights blade, and go through a typical failure diagnostics experience. So I can click on failed requests. I can click on a particular instance of the failed requests. Let it come. I'll zoom it in a second. And I can click on a particular instance. So we'll see more details. So we had failed request charts. So we are collecting failures from your client side, server side, dependencies, and so on. And you get an instance level view of each of these failures. I can see an actual failure, see the exception stack trace, dependency calls, and whatnot. So if I'm using Visual Studio, I could even jump to code, click on that exception message, jump to code, go to the exact method that the problem was in. Now, after APM, we have this button here called Analytics. So if you click on this button, you can jump to our analytics portal and be able to run queries on top of your data. So I had already clicked on that to save loading time. Now, this is our analytics dashboard. That if you're new to the analytics experience, it can give you a lot of tutorials, sample queries to get you started. So you can do stuff like usage reports, performance, errors, and various different visualizations that Evgeny will talk about in a few moments. But just to give you a teaser on what we are looking at, so I'll click on a performance query, which says, essentially, show me the request duration in the last 24 hours, bucketed by percentiles, which are generated automatically. So you can see the query here. It's a simple SQL-like query in a piped format. And again, Evgeny will drill down into the specifics in a bit. You will see visualizations on top of that. You can transform these visualizations. And the most interesting thing is the amount of time it takes to mine through your entire data. So we have seen in our production service as well, we have billions of data points, terabytes of data, and it takes just a couple of seconds to run through that and give us the results. So one of the other interesting thing is all these queries, KPIs, and creative charts that you are creating, you can export it, let's say to Power BI, and create those dashboards that your leadership team or your bosses might want to look at. Or if you are the boss, you might want to look at on a day-to-day basis. So as an example, we have this dashboard here that our team looks at on a day-to-day basis. That's our backend production dashboard. And you can see all these aggregates, metrics, charts that we have created using these analytics queries. And these are the ones that we actually use for our production monitoring. So that's a teaser on what's to come in the deep dive, various different scenarios. So I'm sure you are quite excited to begin. And with that, Evgeny?
Thanks, Rahul. So before we get into the demos, I just want to dive a little bit deeper into what analytics is. We'll be really quick here. Imagine that outage that Rahul was alluding to. It's the end of your day. You really want to go home, and yet you need to resolve this before your bosses get there and start asking you all sorts of questions about why is my customers complaining, why are we losing money, et cetera, et cetera. So what can analytics do for you? Well, first of all, it can let you query your data in an ad hoc manner. Why is this important? Well, you've built all these great dashboards, but chances are if you had these dashboards, if you had the alerts set up correctly, you already would know what the outage is and how to resolve this. With an ad hoc query sort of paradigm, we are now able to come in and using a very simple language, actually figure this out in case we don't know what's going on. And this becomes really powerful to not just detect outages, but also do things like usage analytics, as we'll see. The other really cool thing here is to get started and start querying your data like this, all you need to do is instrument with application insights. If you're in Visual Studio, for most cases, that's as simple as right-clicking on your project and saying add application insights. For other scenarios, we have open source SDKs that you can integrate for most platforms that you'll be on. And drop by and talk to us. We'll tell you exactly what to do in your scenario. So about the query language itself, we start with very simple operators like filter. Let's say we have complaints from Asia, as Rahul mentioned. I can filter down to a specific geo in just one line and start analyzing things that way. I can start joining with other data sources. I can extend calculated columns. I can calculate statistics. It's incredibly powerful, and I'll show you exactly what that looks like in a second. And finally, we have machine learning algorithms to help you detect these patterns, because ultimately, you want to find out what's down or the common patterns amongst your users, and we have some ML that will let you do that. Finally, it's extensible. You can save and share your queries with your coworkers, or perhaps for the next investigation that comes along. You can export these dashboards to Power BI, or indeed to Azure Dashboard. You've learned a lot throughout the conference, hopefully, about the new Azure monitoring service that we've introduced. And of course, you can export to CSV, where you can process it in Excel, which is really everyone's favorite BI tool. So I also want to tell you a little bit about the title. We called the session Digging into Terabytes of Data. Internally within Microsoft, we've actually been using this analytics platform for a couple of years now. And internally, this is something that we depend on with our lives for our investigations. Right now, we have over 23 petabytes. That's 23,000 terabytes stored. Every day, we ingest an extra 1.3 petabytes. And against all of that data, we run over 10 million daily queries. And the reason I show you this is, first of all, to just convey how big data scale we are, but also to comfort you and let you know that doesn't matter the scale of your application, you'll be able to run these queries against it, get results in a very timely manner, and really harness the power of everything that we've been talking about. So with that said, let's get into some demos. I want to start by just telling you a little bit about how the language looks before we start writing things. It is a custom language that we're using here, but I think all of you after the session will be experts at it. The way it looks, if you've never used a pipe-through programming interface before, and this is very common in, say, PowerShell, Bash, any sort of CLI, is that you start with your data source, and then you put this pipe operator. And this takes the output and pipes it into the next operator. You then execute that operator, use the pipe operator again, and then the results get pushed into the next operator, right? So compared to something like SQL, which is something that most of you might be familiar with as a data processing tool, this actually goes line by line by line, as opposed to SQL, where the entire query is executed and evaluated at once. And this is really powerful in an investigation type of scenario, because you start building up those facets. You look at one dimension, add another line, look at that dimension, add another line, and so forth. So let's look at an example of a query. In this case, we'll be looking at the custom events table. We just put down custom events, pipe operator. We want to look at the events that are called my event. And so we'll simply say where name is equal to my event. Again, pipe operator. Now pass the results of that into the next operator, and we'll take 10 results, which just limits what we're looking at. So it's as simple as that. And so now let's actually start writing some code and see how this looks in action. I want to switch over to a different window here, and I'm going to open a new query window. So let's use a scenario here. Black Friday is coming up. Hopefully most of you are familiar with what Black Friday is. From an operations point of view, it's a nightmare because this is, chances are, when you're going to hit load-related issues with your application, especially if you're a, let's say, web store front end. And so, okay, we're sold on this analytics thing. We want to come up with a few queries to guide us throughout that day and make sure that we're ready. So I'm going to start with the simplest query possible. I'm going to start typing my query name, right? And you see that IntelliSense is built right in. Let me actually zoom in on it for you here. It'll suggest to me all the table names available. In this case, custom events is right there. I'll click tab on my keyboard to lock in that IntelliSense suggestion. And now it'll tell me all the next set of things that I can do. In this case, I simply want to look at the shape of my data. And this is very typical for an investigation pattern. You really typically have a separation of concern between the IT pro who's doing this investigation and the development team who's actually instrumenting your application. And so perhaps there's some change in schema that you're not familiar with that the development team put in. And so you want to start by looking at just what the schema looks like. So I'm going to simply say, take 10. And I'm going to press a keyboard shortcut, which is Shift-Enter, and that will execute the query currently highlighted. If you didn't want to use that, you also have, right now, it's a cancel button, but you could click Run here in the upper right and see what's going on. So here I have random 10 results that came back. And we actually scanned over, I think this is 30 billion rows of data here, and we extracted 10 rows of data out of it in 10 seconds. Right, so what can you do with this data now? Well, let's look at a few things that the experience offers you. First of all, in every column, you have a filter selector, so you can filter right there. You can also click on the column name to filter by that column. And you can drag and drop the column name onto there as a grouping control. And you can do that right server side. Every row also has this arrow operator on the left side. Now, what this lets you do is instead of having to scroll left and right like that and giving yourself vertigo, you can actually press this arrow and it will give you all the data in a much easier to read fashion. Now, for custom fields, like let's say custom dimensions and custom measurements, they actually come through as JSON. And we understand JSON as a first-class object. And so, for example, if I wanted to, instead of trying to break my head and figure out what all of this means, I can, again, click the arrow over here and see the JSON in a much easier to read format. OK, great. So now we've seen what the data looks like. We know what we're looking at. I'm going to start with the next query. And notice that I'm not modifying the existing query. I keep on typing a new one in. And this becomes really powerful as you're going back and forth and investigating various facets of your application. This is really how we do it ourselves. So again, I'll start with custom events. And again, let me zoom in here for you. And I'll press Tab. This time, I want to do some filtering. I don't care about all the events. I want to look at a specific event. First of all, in Black Friday, note that I don't want to look at the entire data set I have. I want to look at recent data to see if there's any events happening recently that I should be concerned with. And so I'm going to say where, and I'm going to use the timestamp field. Timestamp is a field that every single data point that you ingest in Application Insights will contain. It gets essentially set when the event gets logged and then pushed down as part of the call to our APIs. So I'll say where timestamp is greater than ago 24 hours. Ago is an operator that lets you essentially do these timestamp range things instead of having to worry about date times and all of that format, right? So I can simply say 24 hours, or I can say 1 hour, or I can say 1 day, or maybe I want to look at 15 minutes. And it's just that simple. But in this case, I want to look at 24 hours. OK, let's pipe that into our next parameter, which is going to be a particular type of event that I know might be of concern to me, which is an AJAX query. So I want to look at AJAX queries because I know from previous experience that under heavy load, this tends to be the first thing that goes for me. And so I'm going to say AJAX query, just like that. And finally, I'm going to, again, just take 10 results to make the query a little more efficient. And in under a second over here, we're now looking at just the last day worth of AJAX query results. OK, so we're building up on this. The next thing I want to do is actually copy most of this query. And what I want to do now is look at this custom measurement I have instrumented called duration. This is custom to my application. This is something that Application Insights won't know about. This is something I care about, though, and so I want to log it. We can log custom measurements, which are numerical values, and we can log custom events, which are just key value string pairs. In this case, I want to extract the duration. Remember how I mentioned that JSON is a first-class citizen? I can do the same thing here. I'll use an operator called extend. Extend lets me create custom fields, or calculated columns, I should say. What calculated columns are essentially a way to create a new column based on an existing set of columns, be it statistical aggregations or something along those lines. And I can then reuse it further down in my queries. So OK, I'll say extend, and I want to call this new column event duration. And I'm going to now define what is going to be this column. So I'm going to say to double, because that happens to be a numerical value. And I'm going to adjust the JSON by the object model. So I'm going to say custom measurements dot, and I'm going to say duration. Right? We know nothing about that in Application Insights, but we allow you to access it directly. So I'll again execute this query. We'll give it a second. This time, I actually didn't take 10, and so the query is going to take a little longer because, like I said, it's processing 30 billion records. And yet still within 8 seconds here, we get the results. So where is this column, right? What I need to do is actually scroll all the way to the right here. And you'll notice we now have, Zoom in is breaking on me, but here, let me move it to the center of the screen. We now have this event duration column, and now this is a numerical value that we can start reusing within the rest of our calculations. OK, so fine, now we looked at the AJAX query, but now I'm starting to wonder, well, how are the rest of my events doing? I want to do some statistical aggregations across my entire data set. So let's do that. I'll again start with the same query, and I'm going to take out this AJAX query parameter because we want to look at all of our events in the table. Now, what I'm going to do is add a summarize operator. Summarize lets you invoke all of these different statistical aggregations that we have available to you. So in this case, I'm going to use the simplest one possible, which is average. What do I want to average? Well, I want the average of this event duration. And notice, we extended the column, and IntelliSense now knows that this is a data field that's available to me. So I'll auto-complete that, and I'll say I want the average event duration. But I want this event duration sliced by the different event types that I have. And so I'll simply say by name, and I'll hit enter. And here we have every single name of the event we have and the average event duration for it across the last 24 hours. Some of these don't have a value. You don't necessarily log this duration parameter for every single event because it just might not make sense. And so remember that pipe-through mechanism where I said essentially this is my data set now. I have a name column and an average event, or an average event duration column. So I can now keep querying against this. I can say where average event duration is greater than 0, and that will filter out those nulls. And then I can also say order by average event duration descending, and I can cancel out this nulls thing. And I'll run that. And now from that result set, I get all of my different events that have this custom duration field that I'm tracking and ordered by descending rate. OK, so now I'm really concerned about this quick pulse blade and second spend particular event. So I want to see what's going on there. I'm going to copy this first piece here. Sorry, let me select it again. Let me copy it. And by the way, I know I haven't been zooming here for the last few queries, so I'll apologize for that. We'll get back to that. So what I want to look at before I extend this duration, I want to add a where clause, and I want to say where name equals equals. And I'm actually going to copy this longest event that I have. I'm going to paste it in there and take out the extra tab. Right, and now I actually want to look at some additional statistics. The average is nice, but if you've ever worked with customers in, let's say, a retail environment, you have a vocal minority. And their experience is an outlier compared to most of your customers, and yet they'll be the ones who go on social media, who tell their friends, and really spoil the whole thing for you. And so we also want to look at our outliers and see how they're doing. So I'm going to use a different operator here, which is percentiles. And I still want to look at my event duration. And now I can specify percentiles. So if you remember grade school statistics, 50th percentile is your average. But I also want to look at my 90th and perhaps the 99th percentile. And just like that in an operator, I can do that. And now I want to also look at this, not necessarily by the name now because we filtered down to a single event, but I actually want to look at this at an hourly grain. And so we have a very convenient operator for you called bin. And I can say that I want to bin by the timestamp with an hourly grain. And again, we can use that same notation we used for the ago operator to figure out exactly what's going on. I'll run this, and you can see that we have a row for every hour over the last 24 hours. And for every row, we have the 50th, 90th, and 95th percentile. Very cool. The last thing I want to show you here is that I can actually, wrong enter, I have a render command. And what this lets me do is visualize my results as opposed to looking them in the tabular form. This is convenient, but humans are generally a visual animal, and so it's much easier for me to look at the pattern and detect the pattern if I see it in a visual way. So I want to look at it in a time chart form. And so I'll do that, and just like this, you can see my average, 50 or 90th and 99th percentile. And you'll notice that if I was only looking at my average, I wouldn't have detected these spikes over here in my 99th percentile. And these might be the difference between a happy and an unhappy customer. What can I do with this now? Well, as Rahul alluded to it, I can export it to a Power BI query. I can export it to Excel. I can share a link with my colleagues. Or I can actually pin this to an Azure dashboard by pressing this pin button. And I'll have here a list of all the dashboards that I have access to. Right? And now I can start looking at this, and I'm prepared for the eventual Black Friday in this case, or whatever it is you're preparing for. So now that you hopefully kind of understand how the language works and some of the basic operators, I want to walk you through 3 specific scenarios from real-life customers, from some real-life outages and things that we had, and show you how this gets applied. OK. So we'll start with Application Insights itself. Application Insights is instrumented with Application Insights. And so we use it as our predominant monitoring solution, our primary, in fact, only monitoring solution. So I'll show you some parameters here. First, I want to run this query just to show you what the data looks like, and then we'll go into how we created the query. What this query is a custom metric that we defined ourselves, which is essentially customer impact. Right? When this value is low, our customers are doing fine. When we see spikes, we know that something is going on in our system, and we're seeing customer impact. OK, so on this particular time range here that I have, we saw that everything was going fairly smooth, a blip here and there. And then all of a sudden, we're seeing a huge spike in customer impact. So now we want to investigate this. So before we do that, let me just quickly show you how the query is set up. The first section here, and this is really good for operationalizing your queries, is a let statement. I can define a bunch of parameters that I can then modify and reuse in my next queries, as opposed to having to dig through the full query and figure out where I used various dates and times. So in this case, I have an issue start at that parameter and an issue duration. And for my next investigation, I can simply modify the date there and how long the issue's been going on, and the rest of my query will work just fine. Then we're looking at the custom events field. Apologize for that. Let me get rid of that. We're looking at the custom events. We're setting the timestamp to be in that time range we specified. We're saying that we're looking at the part load specifically issue. And then we're doing some regex extraction on an unstructured field that we have, right? So, and then we're doing a bunch more extents. We're summarizing, we're extending, summarizing, extending, ultimately projecting and rendering a bar chart. So just to show you sort of how metrics can be built up within these queries in a fairly easy manner. Okay, so now we know that during this time, application outage or application insights is having some sort of outage or certainly a performance degradation, if not a full-on outage. So now we want to do a bit of a sanity check. Okay, so we know that there's a customer impact. Let's see whether we're having some dependency failures. And so I'll execute this next query, and I'll actually filter out the successes here. We'll see that indeed there is a spike in failures. This query is set up in a very similar manner, so I won't dig into it. My point here is to show you the investigation. The next thing, this is where it gets really cool. I actually want to show you our first machine learning algorithm, which is called AutoCluster. What AutoCluster does is take the data set that you pass into it and detect common patterns within it. So let's take a look at the query and then take a look at the results. The first section here should be fairly familiar with setting up some parameters, filtering some things out. In this case, we only want to look at the failed results, so we'll filter down to that. And we're extracting a bunch of various dimensions from our custom dimension fields, again, referencing JSON as a first-class citizen. And then we're doing this project statement, and this is actually shows us just these columns. And these are the ones that we want to pass through into the AutoCluster algorithm. And then we simply say, evaluate AutoCluster. So let's go ahead and run this and see what the results look like. Okay, so I'll tell you kind of how to interpret these results. Every row represents a pattern that we've detected. For every pattern, we give you the raw count out of the entire data set, as well as the percentage that this particular pattern occurs across the entire data set. And then we tell you what the pattern looks like. So let's look at this first one. 31% of the time, over this time span that I've specified, the part name was anything, but the status was 504, and the status text was gateway timeout. And now I'm starting to get somewhere. Now I know that I need to be looking over here. And then I have this column called load fail reason, and it says backend. This is a custom field that I instrumented. I happen to know that when that says backend, actually a dependency of mine, another application is failing. Luckily, that application is also instrumented with application insights, so I'll switch to the analytics window for that application. Okay, the first query I'll run here is very simple. I won't even show you the data here. But essentially what we're doing is a sanity check. We know from the point of view of the original application that calls out to this application are failing. But let's see if within this application itself, we're also seeing the same failures. Or maybe there's something in the network layer, for example, going on between them. And indeed, we can see that over the same time frame, we have success equals false coming up over and over. So we know that we're definitely onto something. So now let's look at the dependencies and see which dependency of this application is failing. We happen to know that this application doesn't do a whole lot that can fail in the way that we saw. It's likely yet another underlying application. And so two things jump out. We have the blue pattern and we have the purple pattern. The blue one is kind of dying out, so let's see what the purple one is. I'll zoom in on one of these. Sorry if Zoom it cooperates. And we see that this is yet another application called billing prod. And again, luckily, it's instrumented with application insights. I'll execute this query. And again, we see that, yes, we're seeing failures from that direction as well. And then I'm going to look at the dependencies here. You'll notice that this time we have a bunch of colors. But if you look at the legend actually surfaces a pattern. It goes Azure table, Azure table, Azure table, Azure table. And so just with this query, we actually know that it's the Azure table component that is failing. And so for this particular example, we actually got in touch with the Azure table team, and they were having a performance degradation. And so within 10 minutes, and using machine learning algorithms, I was able to go from having my own custom definition of a customer impact, knowing that my customer is impacted, to being able to figure out exactly why they're impacted. So this is my first example I wanted to show you. Next, I want to switch to another application and another investigation that we did. The previous one was more of a live-side incident. This one is going to be more of a code bug that we detect using the same exact algorithms. So I'll run the first query, and I'll kind of tell you what this is. This is actually the MS Health app. So if any of you have the Microsoft Band Fitness Tracker, like most fitness trackers, it has an app that goes along with it. The device syncs the data to the app pushes it to the cloud, it gets processed in the cloud, you get all sorts of insights about how many steps you took, how many calories you burned, all of this. This pattern here that I'm seeing, this is actually a daily user count expressed as a percentage, right? And so you'll notice that at the beginning here, we were having a healthy usage, and then almost overnight, we lost a bunch of users. And so now we're curious to know, well, what's going on? Did we actually lose the users? I mean, this is really bad for the business if the telemetry here is correct, right? So let me quickly show you the query that I used here. And the query you really want to concentrate on is this. This gives you the raw data. Everything else I have in there is to convert raw data to percentiles. Very easy, right? Again, I set up my time range. I look at the specific columns I want to look at. I extract this custom user ID. And I do a summarized D count, which is distinct count by this new dimension on a daily grain. That's simple. So we're going to get to our second machine learning algorithm now, which is diff patterns. Diff patterns is a little bit more tricky to understand, but I'll try to walk you through it. Essentially, diff patterns lets you break your data into two distinct segments, defined however you want. It can be by the time, it can be by some metric that specifies which of the two segments the data belongs to. And then it lets you analyze that data and see contrasts between the two data sets. What patterns are occurring in one segment of the set that aren't occurring in the other segment? So let's actually go ahead and run this query, and I'll show you what that looks like. This one is a little bit more computationally intensive, and so I'd like to just point out that still within 4 seconds, we're getting the results back over millions and millions of rows. OK, so how do we interpret this? Sorry for that. Again, every row represents a pattern that we detect. In this case, we're only looking at 2 columns, and that's app version and this ODS user ID column. So the first pattern that we detect is that app version doesn't matter, but ODS user ID is this nulled out GUID. We're saying that in 90% of the unusual data set, and I'll show you exactly what this means in a second, in 90% of the unusual data set, we're seeing this pattern show up. And yet in only 15% of the OK data set, we're seeing this pattern show up. And this is just, oh, I really apologize for that. And this is the difference between the two, right? And so this is sort of your contrast metric, if you will. And this is really where it gets powerful, right? So this is the thing that really jumps out at us. 90% in one set, 15% in the other. And what it is this 0 user ID. So this kind of gets me wondering, well, if everyone is a 0000 user ID, of course my distinct user count is going to be low. So I'll dig into that. But first, let me show you how I actually executed the ML pattern. First, I define my segment. So I use that extend operator to define a custom column. And I say segment. And we use this inline if operator. In this case, I'm breaking it down by the time range. So I'm saying that if the date time is between that date range, it's unusual. Otherwise, it's OK. And just like that, I've defined a column based on which I can now split my data. And now I execute evaluate diff patterns, split by segment. And I'm interested in specifically patterns where unusual is prevalent, but OK it isn't. So that's kind of how you do that. So now let's look what ended up happening here. I'll execute this query. And we'll just look at the results of it. Again, it's very similar to what you've seen before. The blue line, the light blue line, shows the count of users that are 0000, not the distinct count, the total count. The other line shows you a count of users that aren't 0000. So it turns out that what happened here is that the team deployed an update which broke logging your user ID. And in this case, we can see exactly when the update was deployed, we can see user IDs going down and distinct user IDs of zeros going up. And so we know that this was a code issue, and now we can go fix it, diagnose it. OK, final example I want to show you. And for this one, I'm going to switch back to my PowerPoint. this one is more your business metrics. So hopefully all of you know Solitaire. Probably the most common thing to do when you're waiting on, let's say, a file to download or some long job to complete. So the Solitaire team also uses application insights for instrumentation. You'll notice that they have 5 different game types, and they have this challenge, which is a daily curated puzzle, essentially, that gets out to the users. Users can earn points, do that sort of thing. So I'll show you some of the things that they do with their data for business collection. First one is simply usage tracking. Here's all the 5 different types of games that are provided to you as a percentage of the number of games played and as a percentage of the users who play them. So we can see, in this case, that all users are trying all 5 different types of games, and yet all of them are ultimately ending up picking a different type that they're most interested in. So this now tells me that, okay, maybe if I'm the product manager for the game type represented by green, I need to look at what the blue guys are doing better and why my game type isn't doing as well. Okay, here's a query that the team uses around that challenge game type. And this is something called user engagement. Essentially, they're tracking how long a user spends playing any given game type. And you'll notice that this is set up very simply. It's a little intimidating, it's long, but all it is we're looking at our events table, we're doing some filtering using where clauses, and then we're doing a bunch of summarizes. So if we look, for example, at the very first line on the top right, it defines a metric, and then it just looks at the sum. If the challenge was complete, then we say time spent was what the time was spent, otherwise we say 0. And there's a whole bunch of these. So I'll show you a particular result set. This is for challenges. And again, these are hand-curated. So the team, one particular day, noticed a very big drop in this user engagement metric, meaning that the users were spending a lot less time on this particular challenge than on a typical day. Right? So now we're interested. What's going on? Why are users spending so little time? And why is this interesting? Well, if you're a business owner, if your puzzles are too easy, people aren't going to keep coming back to them, right? Likewise, if they're too difficult, people are just going to give up and again, never use your game again. And so the team was very concerned about this. They went back, turns out that indeed the puzzle was too easy. They learned their lessons about what made that particular puzzle so easy, and now they averted not just the life side incident, but more of a business incident, if you will, where they might have been shedding customers along the way because the games were too easy. So this is yet another example of how teams are using this analytics capability, not just for life side, but also for usage data and for really running their business. This is actually pinned to their Power BI dashboard. They examine it every day during Scrum, and it's a huge dashboard, pages and pages, where they go through various metrics. And so this is very powerful. Now, let's, also the last thing I want to show you is share a story from one of our customers, DNN.NET Nuke. Some of you might be familiar with them. They have over 750,000 websites hosted, huge, synonymous across the industry. Something they told us, and this resonates with a lot of customers, is that this tool allowed them to find insights and solve problems they didn't even know they had. I've even heard the term addictive used from time to describe it. So as you start playing with the data, you notice how you start exploring all these different facets, and you start learning things that really you wouldn't have just if you were concentrating on a specific thing, and the query language is incredibly conducive to that. Okay, that's really our talk. I want to give you some next steps. Instrument with application insights. By default, just by doing that, right-clicking, going at application insights in Visual Studio, you get a lot of this telemetry for free. Start using analytics. Deep dive into your application's data. Start exploring. Do everything that we showed you. And operationalize your queries. Once you've built up a good set of queries, pin them to Power BI, pin them to Azure Dashboard, export them, share them. We also have some resources for you, and the slides will be available later. Reach out to us. Our emails are there. We have a booth, as Rahul mentioned. And you've probably seen this path before. There's a bunch more resources for you. And that's really it. So thank you very much for your time. Please do fill out the feedback. The usual caveats. We'll be around for questions. Thank you.